I'm gonna be talking to?
Yeah.
All right. This is October, what?
23rd.
October 23rd, and we're moving towards running of this, the Nor'easter X24 for 24 horsepower. It will be an 8-cylinder, but as you see now, it's got 4 cylinders. The block is made for 8, we're doing 4. Let me start out with the fuel system as it is. This fuel tank will be mounted here. There'll be a fuel distribution block here out to the 4 carburetors. I have a test stand, and right now it's set up so that this throttle from behind the test stand will operate the speed of the engine. The next thing we're going to need is spark. This is a magnetic drive shaft reader. It picks up a signal, delivers it to this little box, which delivers 2 sparks at the same time, one in a cylinder that's here and one for a cylinder that's coming when it's an 8-cylinder. We're going to run this engine as a demo in an attempt to dyno it for the equivalent of a 24 horsepower system at 1,250 RPM. And that's really where we are. The panel is now blank. It will contain switches, gauges, RPM, etc. And that's where we are today.
Jim, tell me, is the are the cams installed?
One cam is installed, the other cam is right here. This, in the world of art or machine work, is a beautiful job. We have this cam is the 50-degree up, 40-degree down asymmetric pattern, which Professor Norton and I have settled in on as being a real advantage. The cam that's in the machine is laying on top. This one will go up underneath. And this would end up in here. These are the rollers that have been designed to fit in the cam.
And were those machines specifically for this, or are they off the shelf?
No, these are all custom made.
So as it is now, it's stable on the demonstration platform. It no longer is easily flipped over, right?
Oh no, I'm arranging it so it can be flipped over. Everything, including the fuel tank, will be inside of these rotary pieces. These connecting rods, which are taped together momentarily, will be with a disconnecting rod, so you could disconnect these, flip it over, work on it, and then flip it back.
Okay. So before firing it up, these open areas will be, they're going to be blocked off.
Yep.
And how has the screwing gone? The
It's precision made.
yep.
It's like a dream. It fits the way the expensive car makers wish they could make things fit.
So are there implications now, as you've seen this come together as a demonstrator model of the X24, are there implications for how a production machine will be vis-a-vis the ancillary components, fuel tanks, starter, etc.?
Starter, as I see right now, will be under here on this model and probably stay there.
Mm-hmm.
If it rotates into a horizontal use, a few things change, but not many. As far as production, at least early production, we're basically ready to go with all the parts that we manufacture. Bigger fuel tank, different distribution of the electronics. This is, I didn't mention, an oil system, even though it's a two-stroke engine.
It does
It's-
require,
It does have the ability to be lubricated in a very standard automobile fashion. The oil comes in here, lubricates the entire inside, comes out the bottom and recirculates.
okay. So for now, for demonstration purposes, there will be a pump in the console here?
Yep.
Okay. Also, question I had regarding are the pistons in there now?
No,
They're not.
no. When this is finished, I'll disassemble the whole top, lift it off, put it into storage, and then go about putting the internal pieces in.
Okay.
There's still quite a little ways to go.
Yeah. Well, it looks beautiful.
I think it'll run beautiful. The interesting thing about this, and Professor Norton's predicted it, that you'll see there's no shock mounting to this engine. If he and I are right, people will notice that you don't have any shocks. You're not going to need shocks in this engine. This has the potential to be as smooth a running internal combustion engine as has been around. There'll be no shaking or vibration.
And that's because of the complete symmetry in terms of oppositional forces?
Exactly, yeah. And all motion is offset by equal and opposite motion. And in addition, when this cylinder is through its combustion stroke, this cylinder fires. And all four odds fire, then all four evens fire. So it is extremely well balanced. And Professor Norton, who wrote the program, is predicting that this will be as smooth as engines have ever been. We're off and running. That's the throttle. And this is the spark advance.
All right, should we get lunch?
Let's get lunch.